Okay, we ready to do a bit more? Right. Yeah. This one won't be. Last week they gave me a microphone for it, but the microphone didn't work, and you were just listening to the inside of my pocket. Okay. You could hear some of it, but yeah, it was fairly. But this one's going to be perfect. Yeah, it's something that just came up in being asked a question about D values and T values, and a thing that's useful for you to do. I don't know. Maybe I'll ask you a question about it as well. No, I said to you, when does the D value? When do the D value and the T value become identical? What size do they become identical? And the answer, what sample size at which sample size they become identical? And the answer would be infinite. But you should have a look, get a feeling for it yourself. So if you use the T inverse function, TIMV, the arguments that you need to put in the brackets behind that are the degrees of freedom, which is typically the sample size minus 1, and the confidence limit that you're working at. The confidence limit is 95%. But you write the complement of that, which is 0.05. All of that's written down on here anyway. Okay, but what I'd like you to have a little play with is changing that the degrees of freedom. So, you know, we've said that if you've got a sample size more than 30, then you should be able to use the D value instead. You know the D value is 1.96, and in fact, you're going to work out D values from that spreadsheet that you're doing yourselves. How big do you have to make the sample size in order to get close to 1.96, or something that you think is close to 1.96? Just have a little play with it, just to get an idea. You know, what you've been told is once you get a sample size of 30, then just go ahead and use the D value. But really, I think there's a difference. I wouldn't use it, and particularly because it's no sweat just to use the T inverse function. You could use the T inverse function for any sample size you like, rather than using a D value. Okay. Yeah, I'm not going to spend long on this because the bulk of this is there's some fairly big PowerPoint presentations that I've put together, and rather than me talking through a PowerPoint presentation, it's best that you look through them yourself. But to be fair to you guys, because ultimately there's an assessment on this, I want you to know the material that's on here is contaminated land legislation and UK risk assessment. It's full of really, really useful and important information that anyone that's going into consultancy should know. But I'm not testing on every little bit of that. It's pointless. I don't want you to just learn loads of facts about stuff. But what I do want you to pick up from looking at these, well, I'll come to these first of all. Like there's themes. What you should recognise is there's particular themes in this. There's the evolution of contaminated land management in America, the Netherlands, and the UK. Just as I don't know. I work in this. You know, I have a business, and we try and make money out of this sort of thing, and it's taken me a long time to sort of figure out what's going on, and it would be really good if I could get you to understand that without you having to go through all the pain of getting it wrong like I've done for years and years. And it's recognising that there's science, and then there's actually what goes on out in the real world. So what I want you to try and pick up on in looking through this is the connection to the science and the difference between what we know scientifically and then what people actually do. And it will help you an awful lot in when you actually go out to work. Yeah, this relationship between science and regulation. because you'll find that there's quite a big gap between science and regulation, and the way that regulation forms. We sit here, well, I'm dragging you into my little grief hole over this. We sit here thinking, this is the way the world works. We do the science, we do the measurements, we do all this, and this is what happens. This is what should go on. We should do it this way. This way is better. But the transfer of that into what actually happens is only mediated really by cost benefits and savings, really. And in lots of cases, particularly with contaminated land and many other things, can get away with not running things in an optimum fashion. We get caught up in trying to do things optimally here. That's our role, to try and find out what's the best way of doing something. We go into the detail to find out what's the best way of doing it. But largely, out there, everything's going along fine anyway, thank you, really. So why would you need to do anything different or anything better? Typically, the only reason why people do change to do things different or better is because something really, really bad happens. So for my business, the best thing that happened was that a load of people got blown up in a methane gas explosion. That's what makes things change. Okay, and you can recognise that sort of thing in this evolution of contaminated land management, the way that it proceeds. All the time you can be thinking that the gap between the research that you do and what actually goes on. The link really should be negligence. Okay, and it's useful for you to understand this, that if you have to go and do a site survey to say whether it's safe to build on a site or whether there's contaminants coming from a site or something like this, then what drives the company to do it right and to do it in the optimal way, the way that we think it should be done as scientists, is the risk of being negligent. The legislation is typically based on someone being able to show that someone's been negligent in the way they've carried out the investigation. And the way that you show that you weren't negligent is by referring to the best practice. If you can say that you've done whatever is the best practice, then that's your best defence against being called negligent. Okay, and that's the way that it would work. The question then is, how do you define the best practice? The best practice is really what people have done up to that time. So you can see the difficulty then in trying to do something new and better, because to not be negligent, what you need to have done is do what people have done up to that time. But things do gradually improve little by little, but you can see how it's slow, and it's slow because it runs as negligence, and you can say you're not negligent if you've done what people have done before, and that you've used best practice. Now, that was fairly sort of downbeat for me to realise that, but more recently, I speak to my friends in consultancy, and I'm always, and a lot of the work that you might do will be things that are, you're doing bits of research to try and change best practice, to offer a new element to best practice, whether it's a way of making some measurements or whether it's a way of changing some parameters in a model. But you're trying to say this should be the new best practice. I've done this work and it shows that you should use this as a new best practice. So in talking to people more recently, you don't even have to use best practice as to say that you're not negligent. You're not saying that you use best practice, you're just saying you're using normal practice. Okay, so it's not even best practice anymore. So that makes it even harder for you to move science actually into the legislation, because the driver in the end is whether or not people get proven negligent. And to say that you're not negligent, really, you're not saying we use best practice, you're just having to say we use normal practice. And then on top of that, in order to be judged if you're negligent or not, you're being compared to previous best practice or normal practice. That's being compared to precedent, okay? And that's what, effectively, it's a common law thing, negligence, and there needs to be precedent lodged that you're judged against. What happens quite often is that if there is something that goes very badly wrong, so a colleague of mine is working on somewhere where I think there's 73 houses where they've been badly contaminated by volatile organic carbon compounds, and there's been some health effects. So it's a very, very big lawsuit, a lot of money. There's several millions of pounds that are involved in it. But the company quite often will decide to settle rather than actually let it go all the way through the courts. Because it hasn't gone through the courts, it doesn't enter into precedent. So it's not down there as a precedent. So by settling, it means that it doesn't get into precedent as well. So that's what's actually going on out there. Anyway, that's so you know, that isn't on this PowerPoint. But on the PowerPoint, as you work through it, the things that I want you to pick up then, this evolution of land management, what do we mean by a tiered approach to assessment? Do you know what, these are things that when you're at an interview, if you can make it apparent you know what these things are, you'll do very, very well. However, when you look at this, it's not complicated, okay? But just know what a tiered approach is. It's what you think. You do this, and then if it's bad, then you do this. If it's bad, you do this, rather than we just do this. So quite often, you look, if it's not bad, you don't do any more. If it's bad, you do this. Next step. That's all it is. But just use the right words and know what the words are. Also, this is typical for almost all these things, comparisons of qualitative versus quantitative. You know, any guidelines that are actually quantitative and those that are qualitative. Notice the use of guideline or trigger values versus site-specific criteria. So guidelines or trigger values you'll hear talked about quite a lot, and they're things that we just generally apply. You know, if you've got 5% methane, then you have to move up to the next level of investigation, and that's a trigger value. However, it might be that your 5% methane really is unimportant when you get down into the site-specific criteria, because it may be that you've got a high methane concentration because you've got some buried peat. It's not producing a lot of methane, it's just a high concentration rather than a large source, these sorts of things. But just recognise the difference between guideline, trigger values, and then site-specific. You'd like to be able to work from generic information, apply a generic standard across everywhere, and then you wouldn't have to do the site-specific work. But we don't have sufficient detailed understanding of everything that we can just work generically. So you have to do some site-specific work. Site-specific is when it gets expensive. So the guidelines and trigger values are things that you'd use on particularly a desk study. So you do a desk study which is inexpensive, and then if you have to then move up to another tier of assessment, then you get site-specific criteria to understand what's going on. And this balance between generic and site-specific. They're the themes that you should bear in mind as you're going through the presentation, and then specific questions that might actually be on a test. What are the main statutory instruments related to contaminated land in the UK? What is risk? That's a typical question that you get asked at an interview as well. What is risk? Let's have a definition of risk. What three things are recognised for a risk to exist? To what contamination does Part 2A not apply? Know what Part 2A is. And these are just typical kind of things you get asked at an interview, and they're also easy enough for me to ask as a short answer question. So make sure you can answer these. Go through the presentation thinking about these themes, okay, and that should be the best use of your time. Yeah, and this was the general reason for doing this was contaminated land really is our general kind of case study for, you know, in the end we're preparing you for doing your research projects which may or may not be on contaminated land, but contaminated land is just a very good case study for us because it is so relevant to lots of the work that you might do. But within it covers a lot of the processes are common to other areas that you might work on. The approaches, all of this is common, and that's why we're using it as a case study. Okay, so there's that one. And yeah, there's another fairly large presentation that you can work through, which is problems in measuring environmental systems, which is a general thing. You know, how do we do measurement in environmental systems? Clearly that's part of this course, measuring and predicting. But there's a specific example here, and this is about doing ground gas measurements. Again, it's important for a large number of people that are going to go into that sector, so it's directly important to them. But the general points about measuring in environmental systems are going to be common to everybody. It's something that I do work on, so that's, I guess, why it's there. There's themes there, which are guidance rather than rules. And again, this is come back to this what you might expect to be going on. And you know, even people that work in this will say to me, "Oh, well, you know, we're going to make a load of money selling this because the legislation must say that you've got to use it." You'll find there's very little legislation saying you have to do this, you have to do it this way. There is some, but there's very little legislation. Mostly what there is best practice, and the best practice is there in order to be a defence against negligence. So a lot of it is driven by negligence, as I said before. So, but look at that as for this theme of guidance rather than rules. So a lot of the work that I've done is to feed into new guidance. What I'd like to do is to feed into a new rule. The new rule that says you've got to use this particular sort of equipment that I happen to make. But they don't do that. There aren't rules, but there is guidance. Difficulties are represented through sampling of environmental systems. So ground gas is a typical thing that's measured in environmental systems. This presentation covers why it's difficult to measure, and the reasons why it's difficult to measure are common to lots of things that you need to measure in the environment. And one of these big difficulties, not just for ground gas, but many other things, many pollutants that move in the environment, is this issue of measuring flux rather than concentration. So look through this bearing in mind flux and concentration. It's going to come up when we talk about stuff we do on the field trip, but it matters across the whole, really, all of environmental science. It's a big deal looking at the difference between flux and concentration. Concentration is generally easy to measure. Take a sample, you've got the concentration. In order to measure the flux is a change over time. So immediately you can't do it from one measurement. Okay, you need to have a dynamic measurement in order to measure a flux. If we think about ground gas, for instance, but you should be able to apply this to other things as well. With ground gas, we're actually interested in concentration. The primary interest for ground gas is concentration, because the hazard, not the risk, the hazard that arises from ground gas primarily is risk of explosion. So the concentration of methane, which is a ground gas, if the concentration is between 5 and 15%, then it's explosive. So 5% is a lower explosive limit. Once you get above 15%, then it won't explode. There's not enough oxygen. But between 5 and 15, it explodes. So the concentration is critical. We do want to know what the concentration is. However, there's a secondary reason for looking at methane as well that starts out secondary, but it's become more and more important, which is that methane is a very important greenhouse gas. As a greenhouse gas, we're not really interested in the concentration. We're interested in how much of it is coming out of the ground and into the atmosphere. So we need to know the flux of it. We need to actually know how much of it is there and is actually moving, rather than the concentration. And in fact, even for the explosion hazard, we actually do want to know the flux. The concentration is what matters to us as to whether there's going to be an explosion, but because you can't measure it everywhere, we actually need to calculate the flux. We can only measure the concentration at a limited number of points, and this again, it's not just for ground gas, this is for other things as well. Because you can't measure it everywhere, what you have to do is measure it in a few places and then predict what the concentration is going to be where you're interested. If you're trying to predict what the concentration, if you're measuring at point A and you need to predict what the concentration is going to be at point B, then knowing the concentration at point A isn't that useful. But knowing the flux, knowing how much is moving, is what you need to know in order to be able to predict what's going to happen at point B. So even for explosion, we need to know what the flux is. And working out flux is much more difficult. Okay, and we'll be doing that on the field trip when we're looking at water and water movement. We'll be getting samples and measuring concentration, but we also need to measure the flux. And typically, the flux is disregarded because it's so difficult to measure. So the Environment Agency that monitor the waters in this country have a very large number of concentration measurements. They go out and do lots of sampling for concentration, but they don't have anywhere near as many places where they measure how much is moving. Now, there's lots of good things to be said about concentration. If you're a fish, then you're bothered about the concentration of cadmium that's coming towards you. So it does matter for things that live in the water. Concentration is the most important thing. If you're trying to understand where the source of the pollutant is and how to manage it, then you do need to also know how much is moving. But just be aware of these two things, concentration and flux, and why it's difficult to measure one and when it's important to measure it. So that's one of the main themes. The specific questions, which are related to ground gas: to what hazard is ground gas concentration relevant? Giving it away, really. Explosion. To what hazard is ground gas flux relevant? What are the main drivers, with two V's, in changing ground gas concentration? And if you really couldn't get enough of this, you can download a longer version as well, with sound. All right. In fact, it's there for you. Okay. The next bit, actually, I'm going to... Yeah, I'll leave it. You can look at it, but I'm going to go through that tomorrow. You don't need to look at this. But if you can do. But this is about the field trip. I'm going to explain what's going on the field trip. You don't need to bother with this at the moment. All I want to do is just to show you. What I'm going to do, I'm going to grey out the field trip thing, so you don't bother with that. But you should be able to see this, which is the first part of the predicting section. We need to just move on to the predicting thing a bit because we've got a lot of stuff to try and get through. So the best thing to do is to read through this. But it's doing two things. That's why you should just read it, really, because I'm going to tell you, after completing this exercise, you should understand what's meant by modelling and why it's an important process to environmental problem solving. I want to make the link to modelling as an approach to doing environmental science, because that's, again, when you get your jobs, you're inevitably going to be involved in models, and just to understand what they are, you've been doing them already. We talked about measurement being a model, so it's nothing that's very difficult, but you just need to put your mind into that way of thinking, particularly because when you're working with people that work at models, you've got to use the same terminology as them, and that's the other part of this, just to be conversant with the vocabulary of model development and use. So that's from reading through this. So I'll leave this up as well, so you can have a read through that. Okay, tomorrow, we're just going to spend an hour together, and it's been moved, so I have to do it in the morning. So, and we're in University Place for an hour between 11 and 12. So you've got a chance to look through some of this stuff. If you've got any questions, then ask about it tomorrow, and then we can just go through a little bit more tomorrow. But if you can try and get through this stuff really by next week, because then we can move on to looking at some of the prediction stuff. Okay. Is that all right? This will have worked now, so I'll stick this up. But I'll see you tomorrow.